if you allow, I want to a little speak about my country and my university. 5 minutes only. Okay. Is it visible for all?
Yes, clear.
Thank you. I am from, my name is Bekzodjon and I'm from Uzbekistan. I work at Samarkand State University. I would like to introduce you about a little about Uzbekistan. Uzbekistan is one of the new independent countries of Central Asia. We located in Central Asia, and our population is about 34 millions. It looks like it Malaysia, and most of our people are Uzbeks and Muslims. We get our independence in 1991 from Soviet Union. Our national independence day is 1st September. Largest cities of our country are Tashkent, Namangan, Samarkand, and others. Samarkand is one of the ancient cities of the Uzbekistan, also of the world, I can say. We're proud of our great scientists like Al-Kharazmi, Mirza Ulugh-Bek, Ibn Sina, and of course about Samarkand State University. Samarkand State University was founded in 1927. We have 76 undergraduate areas and 55 specialty of master degree. Our students about 26,000 and about 10,000 of these are part-time students and others are full-time students. Samarkand State University is one of the biggest university of the Uzbekistan, and in national ranking we are in 3rd place. Also, we are trying to apply for world rankings, and in quiz rankings we got in local ranking in we are in PAC ranking. In the university we have 19 faculties, about 1,000 teachers, about 50 persons with the scientific degrees. Some pictures of our university. This is Faculty of Mathematics, Biology, also biology. This is Faculty of International Program. It means that we have about 9 joint programs with many countries of the world. This is the Faculty of Joint Programs. So it was about a little about my university. I will So our today's webinar theme is mathematical models of suspension filtration in porous media with multistage deposition kinetics. First of all, I want to give some definitions which is used in the presentation. First of all, what is suspension? Suspension is defined as a heterogeneous mixture in which the solid particles are spread throughout the liquid without dissolving in it. So solution is in the solution the fluid is homogeneous. That means that particles are not solid. In the suspension, some particles are not dissolved in the liquid. For example, muddy water, milk of magnesia, sand particles in suspended in the water, pines which dyes are suspended in turpentine oil. They are examples for suspensions. What is porous media? A porous media can be defined as anything that is comprised of a solid matrix and voids, or simpler, a material that contains pores. Examples are soil, sand, cemented sandstone, and others. Here is examples of porous media in the nature. They are porous sand, honeycomb, rocks with oil, lattice frame material, metallic fiber, and metallic foam. Usually, the porous media's cross section looks like this one. And typical grain packaging are presented in many forms. So what is filtration? Filtration is process that separates solid particles from a liquid or gas by passing the mixture through a filter. Here is some examples where filtration is occurs. So, types of filtrations. In filtration of suspension in porous media, two usually used. They are cake filtration and deep bed filtration. So surface filtration or surface filters used for cake filtration, in which the solids are deposited in the form of cake on the upstream side of relative thin medium. It means that size of suspensions particles are larger than size of medium or size of pore of medium. In this case, the filtration deposition occurs on the filter. Second one is deep bed filtration. Deep filters used to deep bed filtration, in which particles deposition takes place inside the medium, and cake deposition on the surface is undesirable. It means that particles of suspension is smaller than diameter of pores. Then filtration or deposition occurs in the filter. So stages of filtration. Usually there are three stages of filtration. They are ripening stage, working stage, which occurs many time, and breakthrough. It means that filter is unusable. About models of deep bed filtration. The models can divide it into two parts: microscopic models and macroscopic models. In microscopic models, we can in microscope, for example, for microscopic models is trajectory analysis. For microscopic models, we can, for example, phenomenological models. In trajectory analysis, equations are derived to describe only for one particle motion, and the equations are given is trajectory. It means that only one particle and one grain of porous media is analyzed, and it will be the equation will be is a trajectory equation. The trajectory of a particle, which describes the particle's path, is it moves past the collector, is dictated by the forcing acting on the particles. It is, for example, the mechanisms of filtration are, for example, in A, it is straining, sedimentation, interception, diffusion, and hydrodynamic dispersion. In phenomenological models, filtration process is described as a change of concentration of the suspension particles with the time, where we use conservation law with combine it with an accumulation kinetics equation. In the phenomenological models, balance equations are in one-dimensional case given in particle differential equations in the form of this one or this one. The first one is without diffusion. The second one is with diffusion. Here, C is concentration of suspension. Usually, we use volume concentration. It means that C measures in meter cube divided by meter cube. V is the filtration velocity. M is porosity. Rho is the concentration of deposition. It is also usually used as volume concentration of deposition. T is time, and X is coordinate of space, and D is diffusion coefficient. In the phenomenological models, the balance equation is followed with kinetic equations. Overall form of kinetic equations is in the form this one. Here, lambda rho is the coefficient characterizing the kinetics. For lambda, many formulas are derived. In our case, in my work, a phenomenological model of suspension filtration in porous media with two deposition zones and multistage deposition kinetics is learned. This kind of processes is widely used in different industries such as food industry, environmental, pharmaceutical, oil, and water treatment. For example, in the oil industry, suspensions are applied in the well drilling and oil production with secondary and tertiary recovery. In water filtration, the fluid is water. The suspended particles can be inorganic, organic, or bacterial matter. We use following physical representation. Deposition in the porous space of the deep filters have two forms. washable, and non-washable, which means washable means that particles which are deposited can be particles. Washable means that particles that deposited can come back to flow and wash with the water. And non-washable means that particles have been deposited never go back. Accordingly, the filter zones are called active and passive. These are from Venezianov. Washable deposition concentration we denote with rho A. Non-washable deposition in passive zone we denote concentration we denote with rho P. Also, we denote the capacity of the filter rho zero. So rho zero is equal to rho A0 plus rho A0 plus rho P0, which are the capacities of active and passive zones. Here, capacity means that the volume of filter we consider is semi-infinitive homogeneous porous media.
Professor, you can off your video because if you face any internet connection, then we will receive a very bad internet connection here, right here. You can just off your video.
Okay. Is it now?
We can't hear your voice. Okay, right.
So we consider a semi-infinitive homogeneous porous medium with initial porosity M0, fill it with a homogeneous liquid, means liquid without dispersed particles. Point x equals to 0, beginning with constant concentration 0 and filtration velocity v0 injected. System of equations for suspension filtration. Second equation is kinetic equation for active zone. We use following representation to develop this model. Surface area increases accordingly because the filter charging. This is here. First stage is filter charging. Filter charging is significant. Its initial stage lasts and the substance in the medium becomes covered with a monolayer of particles. As soon as the particles begins to interact first of all with the previously deposited layer, retention and the filtration cycle enter the next stage. The process of deposition of suspended particles and the stage both this is deposition and this one means release of deposited particles. Of the from the source concentration reaches to rho AR. At the final stage, the deposition of particles reaches the maximum possible rho A0. This is third stage here. It's the active zone of the filter completely saturated with the deposition, and the further deposition of particles does not change with time. Means that rho A don't changes, equals to 0. Change of rho A is 0. For passive zone, when deposition concentration reaches for rho P1 begins aging, it means that compaction. In this stage, intensity of deposition increase due to deposition begins compaction here. First stage is normal and second stage is here compaction. It means that intensity of deposition has been decreased. Here also in passive zone also the maximum when the rho P reaches its maximum value, it means that deposition to initial and boundary conditions are in the form 4. In order to solve problem 1 to 4, we applied the finite difference method. In the domain D, we introduced the following net, omega h tau. Now, instead of functions C, rho A, and rho P, we use net functions CEG, rho EG, and rho P EG, determined and omega h tau. On this net, we approximate equations 1, 2, 3 by following implicit finite difference schemes. This is for equation. This is for equation in different kinetic equation of passive zone. So in order to solve this system of linear equations, we use Python, especially we use the module NumPy, and we use following values parameters, and the program is very easy, and we get following results. Here is described profiles of concentrations C, rho E, and rho P with following values of parameters. Graphics over time, the values of C, rho E, and rho P at fixed points in the reservoir increases. At approximately t equals to t to x equals to 0 here, the capacity of the passive zone is completely filled with the sediment or deposition, and this leads to increase the concentration of suspended solids in the liquid and sediment in the active zone also here. In the second figure, we show the in order to how rho P1 in order to estimate the role of rho P1, we show some graphics. From graphics, we can find that the increase of rho P1 leads to progressive dynamics of C, rho E, and rho P at small x, and the relatively large x's, the opposite picture is observed here. Here is rho P progressive, and here after some x, here is opposite picture. For active zone, we estimate the role of charging effect. The charging effect in the active zone significantly affects the concentration change profiles of E. Increasing parameters rho E1, two zones are formed. One is rho A smaller than rho row E smaller than row E1, and the other here you can see this one is smaller, this one is bigger. In these areas, characteristics have different rates of change. The rate of change in the concentration of deposition in the active zone also affects the characterization of concentration of suspended particles C and deposition in the concentration of deposition in the passive zone, row P. So, thank you for your attention.
Thank you, Prof. Bekzodjon, for your presentation. Even though we have a internet problem here, hopefully those who are in this area could understand what you presented just now. Thank you again. I think it is informative and hopefully interesting to others who are in this area. And now we come to the question and answer session. If anybody participant in this room would like to ask you anything, any question, I open for question and answer.
Yes, of course.
Any question again for Prof. Bekzodjon? Waalaikumsalam. Filtration.
Thank you for question. I not used this. I didn't apply this for masks because I learned only filtration of fluids, not filtration of gases. I think it is also interesting filtration of gases, but we not yet learned the filtration of gases. We learned only filtration of fluids. Filtration of fluids. Thank you.
Any other question?
Assalamualaikum, Prof.
Assalamualaikum, Prof.
The equations involved, how do you derive the equation involved and also the parameters involved?
Sorry?
The equation involved, how do you get the equations and also the parameters? How do you derive the parameters?
Okay. So the equations are in the equation, first equation, it means mass balance equation, is from conservation law of mass. Other two equations are phenomenological equations. It means that we use some physical representation and some phenomenological expressions. In values of parameters we get from literature. There are some, not some, many literatures where they did some experiments and get values of parameters. We use the values of parameters from literature.
Okay, Prof. Thank you, Prof.
Can I ask a question here?
Of course.
Yeah, Assalamualaikum and very good afternoon to all. Prof. Bekzodjon, I just have a very simple question. Normally, when we do modeling, we have to state a few assumptions. So I'm just wondering, in this kind of modeling that you just discussed with us just now, what kind of assumptions that we have to attach with the model? Do you understand my question?
Thank you. Of course, we use assumptions. For example, we assume that porous media is homogeneous. It means that in all points, the porous media have the same properties, and we the other is in suspension. In suspension, all particles have the same parameters.
Okay, thank you, Prof. That leads me to my next question. What if you have different, can I ask another question related to that question? Yeah? Hello? Okay, so one of the assumptions now was the suspension have similar size of particles, right? Now, what if you have more?
Of course.
What if you have?
Of course.
What if you have different kinds of suspension going through the same medium? Let's say you have two different kinds of suspensions going through the same medium. How are you going to handle that situation?
Yes. We also learned this kind of suspensions. If you allow, I can show one of my article.
Yes, proceed, Prof.
Just a minute. Here. Will we post component of suspension means if we have many kinds of particles, we can model them separately and get together. Also some this kind of some expressions which is used for the this is used for two component suspension. Was it clear?
Yes, thank you, Prof. Thank you for the explanation.
Yes, any more question?
Maximum speed. If really I don't mention. Oh, sorry. Stages. Yes. Maximum number of stages are 4. They are, first is charging stage. Second is working stage. Fourth is compaction stage. And the last is breakthrough stage. Maximum number of used in literature is 4. Charging, stage, transient, working or transient stage, compaction. For second question, it can be used in water treatment, preparing of drinking water and preparing water, drinking water and wastewater also. And it is also used in oil industry, in secondary or tertiary recovery. We use water flooding. For get oil, we use water flooding, but we know that we cannot use the pure water, so we use usually water with some water in form suspension, and in this in oil industry, it is used in secondary and tertiary recovery. We used this one.
Yes, any more question? Our session is supposed to be end up at 3 o'clock, but I think we almost finish maybe earlier than that. Is that okay, Prof. Bekzodjon?
Yes. I want to sorry for my English. English is not second language for Uzbek. Our second language is Russian. So our English is not excellent. Sorry for this.
It's okay. So if there's no more question, then again, thank you, Prof. Bekzodjon, for your presentation. Finally, we come to the end of the presentation, and we would like to say thank you again to Prof. Bekzodjon for the informative and interesting talk, I guess, to the audience. And also thank you for the audience for the active participation. Okay, hopefully the presentation today will be beneficial for everyone. And again, thank you for your attention. And I would like to make an early announcement that we were going to have our second webinar on maths modeling on another area next week, inshallah. Thank you again, Prof. Bekzodjon. We will see you next in our next webinar.
Okay. On Monday, I will send the theme of next seminar on Monday.
Okay,
Inshallah.
thank you. Sure. Yes, Dr. Novi.
Dr. Sumarni,
Yes.
can we take a photo?
Take photo
Open the video, everyone.
Okay, please open video for all the participants.